So the question you may have asked already is, why are we going to use protocols? And protocols, how can they help us? Well, they can help a lot, but I just want to give you like an example first of all, rather than give you some extended explanation about it and so on. So let's just going to show you an example of using protocols here and how they can assist us. Now, there are many, many other ways how protocols can help us, but I just want to show you at least one. So if we want to compare our position 1 and position 2 here that we've got. Now, we have an origin struct here, which we created in the last video of X and Y, and a position with origin, width, and height. And we want to compare the locations. Are they the same? Well, we could make an if statement saying if position 1 dot width is equal to position 2 dot width, and position 1 dot height is equal to position 2 dot height, and origin, and so on. We could write this. It would be long-winded, and we would have to do it. We could do it. That is a way of definitely doing it. But we want some form of implementation where we could compare both of these two positions within a function that has no idea about the implementation, the struct, or the existence of this one position or this one origin, right? So this function in here should be passed position 1 and position 2, and it should compare whether or not they two are equal, but has absolutely zero idea about position origin, okay, outright. So we've got to have some way of being able to do this. So a way to do this would be to say, use a protocol, which we introduced in the last video, and we're going to make a silly thing here, and it's going to be called isSame, all right? And this protocol is going to say you need to have a property of hash text, all right? And this property is only a getter. That's it. So now position and origin are closed for modification but open for extension, okay? So on that note, let's just say extension and origin. Extension origin, my mistake. And now we're going to say isSame. And in this extension, we're going to implement the hash text property. And we're going to make it a computable property as well, because it doesn't have a setter. So in this, we are going to do nothing more than return a string, all right, with X and Y. Whoops, X and Y. And that's it. We're just literally going to say all of my properties, all of my the content that I have, I'm just going to place into a string and let someone compare it as it is, but is in a string, okay? And let's just copy and paste this to now say position once again. And this is going to be then the origin hash text, because we know that origin conforms to isSame, and then we're going to say then width, and then we're going to say to height. These are all of the properties that position has, all packed together into a string, all right? So now that we have this, we can basically say in this isEqual function, we can say the left side should conform to or is a protocol of isSame, and the right-hand side should also conform to isSame protocol. Now we can say if left hash text is equal to right hash text, and we can remove this return keyword, then they should be equal to one another, right? And let's just print out first of all the position dot hash text, position 1 hash text and position 2 hash text, and run this, and you'll see down the bottom that they are clearly the same here, right? But if we just change them, you'll see that they're clearly at 3, 4, and then 1 and 5. They are different positions, okay? So now if we run isEqual and say position 1 and then position 2, and we run this, you'll see false, by no surprise. And we change this to 3 and 4, and we run this again, and now we can see true. However, let's give position 2 a different origin, right? Let's just move it up in the slightest bit with the origin. Now you can see false, because the string that origin would have created is now different to that of the origin of position 1. So now that we've done this, there must be an easier way to do this. Well, There is, okay, and Swift has already thought about this, and they've given you something that you've just got to implement, okay. So let's just start off by showing you this, and we just say origin. We'll start again. Just needs to implement equatable. All right. Now, equatable is going to come with another implementation that it needs to have, and we're going to let the Swift compiler add the stubs for us. All right. And this is a static function, and it's using the infix operator. Not talked about this yet, and all we're going to say is left hand side dot x is equal to right hand side dot x. And left-hand side dot y is equal to right-hand side dot y. And this is going to tell us everything. If the two of them are equatable, this will now allow us, if we now take the two positions and we say position 1 dot origin is equal to position 2 dot origin, we can now run this because we've now got this infix operator, and it now says, hey, if the left hand side is an origin and the right hand side is an origin, execute this piece of code here. And now you can see false, because they don't have the same coordinates, they don't have the same x and y. But we run it again, they say true. So they don't care about the implementation, they just care about what this one static function returns. Okay, so we can now go even further and say then position, right, implements equatable to, and because I'm lazy, I'm going to let it implement it for us. And now what we're going to do is say, first of all, left hand side dot origin is equal to right hand side dot origin, because we've already done this. And then the left hand side dot width is equal to right hand side dot width, and left hand side dot height is equal to right hand side dot height. All right, so now this is comparing the other parts of it as well, and this time we can get rid of the origin, and we can get rid of the origin on both sides and run this again, and we see true. So let's just change the height to 4.1 instead and run this again. We can get false, and we change it to 4.1 on position 1, and now we get true. So this is how we can use protocols, all right? But as you've seen, we can now basically say, let's say test 1, I'm just going to call it test 1, and say left-hand side, and let's just say t, and then right-hand side t, and it's going to turn Boolean, all right? And then we're going to say, we want to be able to compare these two here, and we're going to say left-hand side is equal to, whoops, right-hand side. This is not going to work. However, to introduce you to something else, we can say, hey, T, the implementation of T, all right, is got to implement, or the concrete class or the struct or whatever it is, the struct data structure of T has to implement equatable. And now we can return this, and we can change this test. We can now, let's just come here and say test 1, and we'll say left hand side is equal to position 1, and this one is position 2, and we run this once again. Now you can see true, all right? But what's fantastic about this is that we can say here right hand side is equal to origin, all right? But this is showing you here the magic of it, because arguments that you're now comparing a position versus an origin, right? So the implementation is different, however they are both equatable. So this is the important part of it, is that both the implementations need to be the same type, right? But they both must implement origin, all right? So if we now create an origin A here, and let's just be precise here, and then we say here, and we'll say 2 and 0, and we say origin A here, and run this. This now works. So even if we can compare here the same types, but they must implement the equatable. So this is how we can use protocols for a lot more, right? And this is called generics, okay? And so the most important reason why we use protocols, in my opinion, is so we can use generics, all right? And when you start looking at the likes of Swift UI, you're going to take one step even further into generics because they had to like readapt generics to work even better. But I'm not going to get into that. But there we go. This is why we use protocols. And there's many, many other reasons, but I just wanted to show you a small portion of why we use protocols. I hope you've got something out of this one video. I hope you've learned something in this one video. If this has absolutely baffled you, blown your mind, and you are like, I'm completely confused, don't worry about it, because most people are when they first get introduced to protocols, and most people are when they start getting told about infix operators and so on, and when they start talking about generics. So you will not be the only person that has real problem understanding this. However, stay with me and I will make sure you understand it. All right. With that said, don't forget to like, subscribe, share, and do all of the other social media things that are out there. It's getting tough right now, so if you do have any questions, feedback or concerns, please let's start a conversation in the comments section down below. Tell me which parts you did or didn't understand about it, then I can adapt the future videos to talk about these things as well. Thank you very much for watching. My name is David Thorne and I will see you in the next video. Ciao, ciao and goodbye.